Alright, so in this video, we will be discussing May-June 2020 paper 6.3 for probability and statistics 2. Let's have a look for question number 1. Alright, so we are given a random sample of 100 values of the x is taken. Then we are given some summarize of the values here. They want us to calculate unbiased estimates of the population mean and also the variance of x. Highlight the keyword unbiased estimates of the population mean and variance. When we want to do any estimation, this keyword is important, right? What's the formula for unbiased estimate for population mean and variance? Right. So basically, just let us recall back, okay? For unbiased estimate value, the mean formula will be similar to what we have in the normal sample mean, which means that we are taking summation x divided by n. And if we are asking for the unbiased estimated value for variance, the formula will be 1 over n minus 1. Then you're having summation x squared minus summation x squared then divided by the n. Okay, so these two formulas basically is still provided in the formula booklet. You can have a look if in case you can't remember it. All right, and then for the variance formula, right? For this variance formula, this is one of them. Basically, we are having two in the formula booklet. So it depends on which one you feel that is more convenient for you to use it. Then you can just apply it. For me, most of the time I'm using this one. Alright, because from the question being asked, usually we are given the value of summation x squared and also the summation of the x. Alright. Okay, so this is the formula that we are going to use here in this question. So let's start to apply it here. Alright, so to calculate the mean, I'm taking summation of x and the value is quite obvious here. It is 1556 divided by the n. What's the value of the n? That means it is a sample size. So sample size is 100 values here. So divide it by 100 and you are getting 15.56. So as long as you see the keyword, then you just apply the formula for unbiased estimated variable. Then it's quite straightforward. Alright. Then after that, let's have a look for the variance. So the value of variance should be 1 over n minus 1. So I'm taking 1 divided by n minus 1, you get 99. Summation of x squared, you're getting 29004 from the question, minus summation of x 1556, and you square it, become 1556 squared, divided by the n, which is 100. Alright, then just make sure that you press calculator. If you didn't do any careless mistake by right, the answer should be a long value like this. And of course, we want to cut it short into 3 significant figures as the final answer, right? Then it should be 48.4, correct to 3 significant figures. Right, so this is how we answer question number 2. We are each day at the gym, Sarah completes 3 runs. The distance in meter that she completed in 3 runs have the independent distribution. We are having 3 types of variable here. One is one is named as W. It is normally distributed. X is also normally distributed, and also Y is still normally distributed. We are having all the normal distributed variable here. Find the probability so that means you're having the P on a particular day, y means variable y, less than, smaller than, total of w and x. So highlight the keyword total. So total means that you are having w plus x. We are trying to convert the sentence into a symbol form, and this is what we want to find out in our question here. They want us to find out this probability. But for this probability, you can see that we are having variable at both sides of the inequality. So to continue with the calculation and find out the answer, you need to move all the variable to one side. So this is what I will make it like this. Alright, so I move both the w and x to the other side, then this is what I get. Of course, some students, they prefer to move the y over, also can. Up to you, the final answer will be still the same. Alright, after I move the variable over, then I want to find out the mean and also the variance for this particular variable first. Alright, then what do I have here? I want to find the mean for y minus w minus the x. And what is the probability here? Sorry, what is the mean here? So for the mean here, I'm having the mean of the y. Mean of y, where is the mean of y? 3860. Minus the mean of w, minus you copy the minus. Mean of w is 1520. And then what is the mean of the x? The mean of the x will be 2250. And the mean value that I get for this particular variable is 90. Next, let us find out the variance. Right, so we are having variance y minus w minus x. So what do I have for the variance here? So let's take variance of the y, which is 1050. This is the variance. All right, then we have to plus. This is a special case here. When we are calculating any variance, right, there's no negative sign. It must be always positive. Therefore, the negative here, I have to change it become positive. So it is a small characteristic for the variance part, yeah? Because variance value should be always positive value, right? Okay, so I'm having plus. Then what's the variance of W? Variance of W will be 450. Then again, we are having a plus one more time here, changing the negative become positive sign. And then what's the variance for the x? We are having x is this one, 720. If you try to add these three values together, by right, you will get 2220. And from here, we know that all the x, y, and w, right, they are all normally distributed. Therefore, linear combination. Linear combination means that you add them together, okay, or you minus them with each other. And there's no square one. Linear means no square, right? There's no y square, w square, x square. So linear combination, if your variable is normal, then your linear combination for all the variables should be also normally distributed. So from here, you should know that the variable of y minus w minus x should be also normally distributed. What is the mean? Mean is 90. And what is the variance here? It will be 2220. And now, according to the question, they want us to find the probability for y less than w plus x, right? The total of w and also the x. But like what I told you just now, we can't find the probability like this. We have to move all the variable to one side. So when you want to move all the variable to one side, it will become y minus w minus x smaller than 0. And this is a normal distribution. Therefore, to find the probability, I have to standardize it become z. How to standardize it? You have to take the x, the value of the variable minus the mean, divided by standard deviation. So what is standard deviation that you have? Square root of 2220. 2220 is a variance, yeah? So when you take standard deviation, you have to square root the variance. Right? Then from here, try to press calculator and get the value of the z. By right, you should be getting negative 1.91. Then we usually want to keep it to three significant figures, three decimal places for the value of the z. So it should be negative 1.910. So just make a reminder here. This one should be three decimal places because according to our normal distribution table, right, the accuracy for the z is up to three decimal places. Right, then after that, I have to take 1 minus, find out the area for this part, for this probability. I assume that most of you already know how to find out the probability in the normal distribution. Okay, so basically you need to know the probability is equals to the area. So you're having negative 1.910 here, same as greater than positive 1.91, and you have to take 1 minus the answer that you get from the normal distribution table. If you are not so sure what am I doing here, maybe you have to go back to your AS syllabus, statistic 1, then chapter 5, the normal distribution, and do some revision on that. Okay, because all these are from the AS syllabus in stats 1 for chapter 5, yeah? Okay, so to find out this probability, I have to take 1 minus, then I try to get the answer for this one. Z equals to 1.91. Z smaller than 1.91. So go to the table, look for the Z, 1.91 is this one. Okay, 1.91 on top, right? So this is the probability, 9719. So I have to take 1 minus 0.9719. And let's see what do we get. If we didn't do any careless mistake, by right, the answer should be 0.0281. Alright, so this is how we answer question number 2. Question number 3. The number of customers who visit a particular shop between this 1 hour duration has the distribution of Poisson with the mean lambda. And you need to take note that the lambda here basically meant for the 1 hour interval here, right? Okay, in the past value, lambda was 5.2. Following some new advertising, the manager wished to test whether the value of lambda has increased. So please highlight the keyword increase here. And one of the keyword is test here. And this question, basically, when you look at this keyword, right, you know that it is belongs to hypothesis test. And when you want to set up the hypothesis test, the word increase will be one of the keyword, will be the keyword that help you to set up alternative hypothesis later, right? Okay, he chose a random sample of 20 days and finds that the total number of customers who visited the shop between 9 to 10 on those days is 125. Okay, so to run the test, right, they are taking out the 20 days. All right, instead of using 1 day, they select 20 days and they try to observe and what is the number of customers that they have, okay, to run the test. So use an approximating distribution, highlight the keyword approximating distribution, to test at 2.5% significance level whether the lambda has increased. Okay, so let us start the test here. First step, you need to set up the null and alternative hypothesis. And from here, you can see the keyword approximating distribution. If you have a look at the first slide, right, this question, by right, we should be using Poisson distribution to carry out the test. But since they asked us to use approximating distribution, so what can we do, or what should we do? How can I change the Poisson to some other thing to carry out the test? The keyword here means that you need to change Poisson to some other thing or some other distribution to carry out the test. Right, but before that, maybe let us have a look for the detail first. So let's have a look for the null and also alternative hypothesis first. For null hypothesis, you want to test the lambda, which is equals to 5.2. But if you try to observe in detail, we are not taking 1 day to run the test. Because 5.2, the lambda is for 1 day only. To carry out the test, we are taking 20 days. Do you see the 20 days here? If 1 day, the lambda will be 5.2, then what happened to the 20 days here? So your lambda will increase also, right? Will change according to the number of days that we have. Therefore, the lambda is not 5.2. Usually for me, my preference is I will write out the lambda for the number of days that we use to observe for the test. So in this case, we are having 20 days, which means that I'm taking 5.2 is for 1 day, and I have to multiply with 20 days here, and the lambda that we want to test should be 104. Okay, so from here I know that to carry out this test, right, my lambda basically is 104. 5.2 is for only 1 day, but I'm having 20 days in total for this case. Right, then how about for the alternative hypothesis? It should be increased. The keyword increase tell me that it is greater than 104. Alright, but of course, if some student will ask, if I write 5.2 as a lambda to carry out the test, can or not? Can. Okay, but of course later you need to know that your lambda for carry out the whole test basically is 104 because we are having the days of 20, not 1 day. Alright, so you still need to apply the approximating distribution to carry out the test later. Right, so this is the first step that we have. Okay, we are carrying out the test using lambda, right? Okay, then originally this distribution is Poisson distributed. The lambda is 104 for 20 days. Then how can I change it to some other distribution? So for Poisson, you can change it become normal distribution, where the mean and also the variance are having the same value. This is a special characteristic for Poisson, right? Mean and variance should be having the same value. And maybe some of you will ask, why or how can I change Poisson become normal? There's one criteria or maybe the condition that you need to make sure that it fulfill when you want to change Poisson become normal, where lambda should be more than 15. So I think this is quite obvious. Your lambda is 104, right? Okay, that's the reason why you have to change it become normal distribution. All right, so you can see that we are changing Poisson to normal. All right, and to carry out the test, what should I have here? I need the observed value okay, to carry out the test. All right, so some students will ask, after I change become normal distribution, right, what is the next step for me to carry out the test? In short, you're having two possible two possible method to carry out the test. You can use p-value approach or you can use the critical value approach. For normal distribution, for normal, okay? For Poisson binomial, the original binomial, original Poisson test, you have to use p-value only. But for normal distribution, it is quite special. You can use either critical value approach or p-value approach, up to you. Both will also give you the same result, right? For me, I will focus on the p-value, okay, where I'm trying to use the original method of Poisson, use back the p-value to carry out the test, okay? All right, so let's continue. To find out the value, p-value, what we need to do is we have to use the observed value of the test. What is the observed value of the test in this case? So I want you to highlight this keyword, this value here, 125. That means when I take 20 days to carry out the experiment and run the test, the value that I observe is basically 125. So I'm having x 125 here. And then for the sign here, I have to put either greater equals to or smaller equals to. Which one is the correct sign? And again, to decide the correct sign, basically you have to look at the alternative hypothesis because you know that your test here is one tail test on the right. When you want to calculate the p-value, you also need to calculate the area on the right-hand side. Therefore, the sign here will be greater or equals to. Okay? Yeah. So for those who need more explanation on deciding the sign when you carry out the test, you can go and refer to the lecture videos that's available in the channel, right? Okay, I want to find the probability for x greater equals to 125. Okay, then how to calculate the probability? So first step, Poisson is discrete random variable and normal is continuous random variable. When you want to carry out the test, you need to make sure that you apply continuity correction. It's either plus or minus 0.5 continuity correction, okay? And x greater than 125, to cover the probability that we want to count in this case, the value of x should shift earlier, which is 124.5. So this is the continuity correction. And after that, only you continue to calculate the probability. And this is a normal distribution, right? You have to standardize it, become Z. How to standardize it again? It's the same like what you learned before. You have to take the value of the x minus the mean. So minus mean that you get is 104 divided by standard deviation. Variance is 104. Standard deviation will be square root of 104. Your value of z will be 2.010. To calculate the probability for greater than 2.01, you have to take 1 minus, then find out the value from the table, 2.01. Alright, so 2.01 by right, you get this one, 9778. So we have 1 minus 0.9778. And after you simplify it, by right, you will be getting 0.0222. And basically, this is your p-value. Okay, all right. And after you get the p-value, what should you do? And what is the final answer or what is the final conclusion that you can make from this test? All right. So for the next step, I want you to have a look by using the diagram since we have changed it become normal distribution, right? Okay, so you're having a normal graph here. Where is your rejection region? Your rejection region should be on the right-hand side because of this one, greater than 104. Greater than should be on the right-hand side, which means that you'll be having a rejection region on the right-hand side. This is the rejection region. And how big is the rejection region? It is basically our significance level, 2.5%, which means that this rejection region will give you 0.025. okay? And I want to put this p-value, which is also the area, inside my diagram here. The shaded area is 0.025. Where should I put the area of 0.0222? So 0.0222 is a smaller area compared with 0.025, right? That means if I want to draw it by using the blue color, this blue color is the area of 0.222, 0.0222, because compared with 0.025, it should be big, it should be smaller. The blue color should be smaller, right? If let's say the blue color area is 0.0222, look at this value of the z here, it falls under the rejection region. Okay, this value is 2.01. So you can see that 2.01 falls under the rejection region. Okay, so from here you roughly know what is the conclusion already, right? So because of this one, we need to make a comparison statement where you can write the p-value, which is 0.0222, is smaller than the alpha, the rejection region, which is 0.025. Okay, some students they might feel confusing when want to make decision using the comparison statement. So for me personally also, I prefer to draw it out so that I can see it very clearly. All right, so you're having a bigger rejection region compared with the p-value that we calculate, right? And if you draw it in the diagram, you can see that the line, the value of the z in the p-value is actually falls under the rejection region. So if it falls under the rejection region, that means when you want to do the conclusion here, it should be reject the null hypothesis. And after that, please make a statement that's in the context of the question, your conclusion in the context of the question. If you reject the null hypothesis means what? Means that the lambda basically has increased, right? Okay, the value of lambda has increased. So you can write out the statement like this, there is sufficient evidence to show that the value of lambda has decreased. Has decreased. I think they are saying increase, right? Yeah, sorry for that. So it should be increased. Okay, so this is how we carry out the test. And just to remind you all, in the exam, please make sure that you show at least all the steps here. The very first step is, of course, the null and alternative hypothesis. All right, then the second step is basically the p-value that you get. But of course, some students, they are not getting the p-value. They try to get the test statistic if you want. Okay. Then the third step is comparison statement, decision. Sorry, this one should be 3. And after that, don't forget about the conclusion in the context of the question. All right, so this is how we answer question number 3. All right, so question number 4. The random variable A has the distribution of Poisson with lambda 1.5. A1 and A2 are independent of values of the A. Find the probability that A1 plus A2 is less than 2. Less than 2, yeah, there's no equal sign here. All right, so what are the steps that we have to carry out when we want to calculate this probability? If you have a look for this distribution, they are having A1 plus A2. Okay, and what is since they are the A1 plus A2, both A1 and A2 are from the variable A, right? And both of them should be Poisson distributed as well. All right, then to calculate the probability, what you should do is try to find out the lambda first for A1 plus A2. Okay, so what's the mean for A1 plus A2? Mean means lambda, right? Okay, so the mean of A1 is 1.5. The mean for A2 is also 1.5. Therefore, the lambda for A1 plus A2 should be a 3. And when you want to calculate the probability for A1 plus A2 less than 2, Okay, so you have to think, what are the number that's less than 2? So you have a1 plus a2 equals to 0, a1 plus a2 equals to 1. Okay, then just to recall back, if let's say you're having a Poisson distribution with the lambda, mean of lambda, how to calculate the probability for x smaller than r? Okay, or we shouldn't put smaller than r, we should just put equals to r. The general formula will be e negative lambda power r divided by r factorial, where the r can start from value 0, 1, 2, 3, 4, 5 until infinity. Okay, if I want to have a1 plus a2 smaller than 2, you can have a1 plus a2 equals to 0 first. So equals to 0 means e negative lambda power 0. So lambda is 3 in this case, power 0, you get a 1, divided by 0 factorial, it is a 1. So you're getting a 1 here. Then after that, a1 plus a2 equals to 1. So the formula is e negative lambda, still the same. And I factorize it out. Then lambda power 1 divided by 1 factorial, and therefore you're having a lambda here. Okay, then simplify your answer. By right, you should be getting 0.199, correct to 3 significant figure. Okay, this is what we have for part A. Then let's continue to part B. Okay, so for part B, given that a1 plus a2 smaller than 2, find the probability of a1 equals to 1. I want you to highlight the keyword given that. So this is basically a keyword to tell you about the conditional probability. So which means we are going to find out the conditional probability in this case. So do you still remember what is conditional probability? Okay, just to recall back. Let's say we already know that something happened earlier. Given that event A happened, find the probability of B. When they give you the structure of the question in this pattern, given that A happened first, then find out the probability of the B happened. So this is a conditional probability. The keyword is given that. And when you want to write the symbol, the event that happened first, you write on the right hand side of the slash, then B is on top. Okay, then how to, what's the formula for this specific symbol here? To find this specific symbol, the formula is A intersect B divided by the probability of the A. Okay, so we call this as conditional probability. Again, for those who already forget the conditional probability, go back to AS syllabus looking for chapter 3. That's a small part about conditional probability calculation, right? Okay, so let's continue back, and we are going to figure out this one. So first step, I want to write out the symbol first. Given that a1 plus a2 smaller than 2, so given that it's a conditional probability, right? Therefore, the symbol should be having the slash. Then this event happened first, so you're having a1 plus a2 smaller than 2. I already know that a1 plus a2 should be smaller than 2. Find the probability of a equals to 1. So the a1 equals to 1, I will write it on top, on the left, sorry. Okay, then this is a general, the symbol for this particular question here. Then what is the formula for conditional probability here? So according to what we have, you are having A intersect with the B. And I'm having A1 equals to 1 intersect with A1 plus A2 smaller than 2. Okay, then divided by the event that happened first. So divided by A1 plus A2 smaller than 2. Okay, done. Right, then now let's have a look for the numerator part. So we want to do the calculation for numerator. We know that a1 plus a2 must be smaller than 2. But at the same time, a1 must be equals to 1. So try to think, what are the possible cases if a1 equals to 1 and a1 plus a2 should be smaller than 2? So it will be having a2 should be equals to 0. Agree? Because if you are having a1 equals to 1, a2 equals to 0, that means 1 plus 0, you get a 1. Which fulfill this condition, a1 plus a2 smaller than 2. So some students will ask, how about if let's say a1 equals to 1, then a2 equals to 1 also? 1 plus 1, A1 plus A2, 1 plus 1 equals to 2, which already out of what we are interested here, smaller than 2. The smaller than 2 means doesn't include the 2, yeah? So A1 plus A2 equals to 2 cannot be counted in this part. Okay, then how about for some students saying that, how about I have A1 equals to 0, then A2 equals to 1. Is this fulfill what we have in the numerator? Also not fulfilled, because in the numerator here, they already mentioned clearly that they want to have the value A1 equals to 1. You cannot make A1 equals to 0. Okay, so in short, when I want to simplify the numerator on top, according to the meaning here, we should be having A1 equals to 1 and also A2 equals to 0. That's only possible case. Okay, then divided by the probability of A1 plus A2 smaller than 2. Okay, then let's calculate the probability here. How to get the probability for A1 equals to 1? Go back to this formula on top, this one. So A1 equals to 1 will be E, negative lambda. Then I'm having E, negative lambda. So the lambda here I'm using 1.5, not a 3. So maybe you ask, why I use 1.5 but not a 3? Because for this calculation, I only focus on A1. Only A1 itself. So for A1 itself, what is the lambda here? It should be 1.5. Okay, then E, lambda power 1. So 1.5 power 1 divided by 1 factorial. So divided by 1 factorial. This is a probability of A1 equals to 1. Then after that, I want to calculate the probability of A2 equals to 0. So again, E, negative lambda, still 1.5. Lambda power 0 divided by 0 factorial. Okay, so just in case that you can't really remember, this one is basically the probability of A1 equals to 1. This is the probability of A2 equals to 0. They are independent to each other, therefore I can directly multiply these two probability together on top, okay? Then divided by A1 plus A2 smaller than 2. So how to get this A1 plus A2 smaller than 2? Let's have a look for the answer on top. We already tried to figure out A1 plus A2 smaller than 2 just now, right? But this is the simplified answer. Maybe I have to put it down first. So to calculate the probability at the bottom, you cannot directly use 0.199, and in fact, you should use the long value originally. So just now I forget to write out the original value for you. Should be 0.199148275. Okay, then I have to put this particular long value here into my calculation in part B. So divided by 0.199148275. Then press calculator carefully. By right, you should be getting the answer like this, 0.374, then 999999. Then correct it to 3 significant figure. Right, so this is basically what we have for the part B. Okay, then again, for this one, you just need to make sure that you have to recall back a little bit about the conditional probability when they give you the keyword given that. Okay, right, then let's have a look for part C. They are asking you give a reason why A1 minus A2 cannot have a Poisson distribution. Okay, so for Poisson distribution, it has a very special characteristic where the mean and also variance is having the same value. Okay, and if you try to have a look for the mean of A1 minus A2, you'll be having 1.5 minus 1.5, which is 0. Okay, then if you try to calculate the variance for A1 minus A2, it should be variance is also 1.5. Then there's no negative in the variance, right? So you have to always change it, become the plus, then 1.5 equals to 3. So it's very obvious that these two values is not the same. Therefore, it cannot be a Poisson distribution. Of course, this calculation is just to show you for understanding purpose. In the exam, you can directly write out the reason where mean and variance for the variable A1 minus A2 are not having the same value. Therefore, it is not Poisson distributed. Okay, so that's the main reason. All right, okay, so this is how we answer question number 4. Okay, so let's continue with question number 5. Sunita has a 6-sided die with the faces marked 1, 2, 3, 4, 5, 6, and then the probability that the die shows a 6 on any throw is a P. Sunita throws the die 500 times and also find that it shows a 6 70 times. Find the approximate 99% confidence interval for P. Right, so for this question, they are asking for confidence interval, but this is for proportion P. All right, so just to recall back, what is the formula for confidence interval for P? All right, so I want to emphasize here, we are having two types of confidence interval in the syllabus, right? One type is the confidence interval for mean, where we find out more commonly, more frequently. Then we have another one, which is this one, where we try to find the confidence interval for P, or we call as proportion. All right, then the confidence interval for proportion basically is like this, yeah. You need to have the P from a sample, okay, then minus Z square root PQ over N. Then the upper limit will be P plus Z, then square root PQ over N as well. This is a confidence interval for proportion. And then we have another type, which is the confidence interval for the population mean, right? And the general formula is you have to use the sample mean. So you're having sample mean minus the Z, then sigma over square root N. After that, also you're having sample mean plus Z, then sigma over square root N. All right, and these are what we have, yeah. So please make sure that you know in the syllabus we are having two different types of confidence interval, right? Okay, for this question we are looking for confidence interval for proportion. How can I get the P? The P means the proportion of getting the event that you want. We are interested to find out the P, the confidence interval for the P, and what's the P here? The probability that the dice show a 6. And how can I get a P in this case? So you can see that we obtain 6 for 70 times out of the throws of the 500 times. So from here, the P to get the 6 is 70 over 500. Of course, you can simplify, become 7 over 50. All right, then we have the P already. And Q is easy. Q means 1 minus P. Therefore, what is your Q here? Your Q will be 1 minus 7 over 50, and you should be getting 43 over 50. I keep all these values in fraction so that I can directly put it in the formula later. Then when we calculate it, it will be more accurate if we press calculator. And what is the value for the N? N means the sample size, or maybe we can say that how many times we repeat the experiment or repeat the throws. So very obvious, in this case, we are repeating the experiment for 500 times, right? So this is the N. All right, and if you observe the formula again, we are having P, Q, and N already. How can I get a Z? So to get a Z, basically it depends on the confidence level for the confidence interval. In this question, the confidence level is 99%. All right, then to get the value of the Z, let us have a look here. 99% confidence interval basically means this one. You want to form a confidence interval where you're having a 99% in the center. So this is 0.99. And after that, where is the value of the Z? The value of the Z means this particular value of the Z. Okay, then we have another Z at the negative part and we put it as negative Z. And this formula, basically the Z in the formula, refer to this Z here. And then this is what we have like if we want to visualize the confidence interval by using the percentage. Yeah? Right, so we are having 0.99 here. What happened to this small area here? So this small area should be 1 minus 0.99 divided by 2. And you are having 0.005. And this diagram is symmetrical, therefore this area is also 0.005, so that when you add up the three area here together, it will be always equals to 1. Okay, and now to get the value of the z, I need this whole area here, so that I can find out the value of z in the reverse way by using the normal distribution table. I want this whole blue color area. If you add these two blue color area here, the whole blue color area here, right, the total area should be 0.995. Right? Then we proceed to the normal distribution table looking for the value of the z. Again, I prefer to figure out the shortcut table first, usually lah. Okay, my priority usually is to look for the value of the z from this small table first. Then if let's say the value is not available, only we look out for the large table on top. Okay, we are interested for the area P, which is 0.995. So you can see here, 0.995 is available here, and what's the value of the z for 0.995? It should be 2.576. Right? Okay, so let us go back to our calculation. The z here will be equals to 2.576. Alright, you successfully get all the information that you need to put inside the formula, and let us calculate the confidence interval here. So what's the confidence interval for the P? According to the formula that we have, what should it be? It should be P. P is 70 over, 7 over 550, right? I simplify 7 over 50 minus the Z, 2.576. Then multiply with PQ over N squared root. So again, P is 7 over 50. Q is 43 over 50. Then divided by 500 here. Same thing happened for the upper limit, just that you change the sign from negative become positive. 2.576 PQ over N. Alright, then just try to press calculator lah and correct your answer to three significant figure. Your final answer should be something like this, 0.100 and also 0.180. Three significant figure. Right, so this is the confidence interval for P that we have for this question. Let us continue further to part B. Okay, Sunita believes that the die is fat. If let's say the die is fair, means that you should be getting the probability of getting the 6 should be 1 over 6 if it is fair, right? Use your answer to part A to comment on her belief. And how can we use the confidence interval to check and see whether what she believes is true or not true? Okay, so when we are having P equals to 1 over 6, if you try to convert it into decimal number, it should be 0.167. Okay, and if you have a look for our confidence interval that we calculate just now, we already carry out the experiment for 500 times, right? And from the 500 times of experiment, we try to get a confidence interval where it says that the P should lies between 0.1 until 0.18. And now I believe that P is equal to 0.167, and you can observe that the 167 lies in the confidence interval that we find out just now. All right, which means that Sunita's belief should be a correct one, right? So this is how we decide it. All right, okay, then let us have a look here. So I will usually write it out. The reason, because of 1 over 6 or 0.167 lies within the confidence interval. Therefore, Sunita's belief about the die is fair is justified. Okay, all right. Yeah, it is because of, if let's say you believe that this is the value of the P, and we try to compare it with the result that we have in the confidence interval that we already carry out. The confidence interval you carry out, we find it out by using the 500 times of truth, right? It is a very huge experiment, right? It's a very big experiment that we try to carry out many times, and this is the range that we find out where the P should be lying between. Okay, and you see that our P really lies between the confidence interval. That means that your belief here is basically justified based on the confidence interval that we get, right? Then let's continue further for part C. Okay, now she used the result for 500 throws to calculate the alpha percentage confidence interval for the P. And the interval has a width of 0.04. Find the value of alpha. All right, so let us highlight this one first, the width. Width, we are having the value of 0.04. Okay, then now how to get the formula for the width in the confidence interval? So width means how wide is the confidence interval, right? And to get the width, you can take the upper limit minus the lower limit. If you use this formula, upper limit minus the formula for lower limit, basically you will get 2z square root pq over n. Alright, so I just try to write out here, the width is 2z, then square root pq over n. Alright, then how can I get the alpha here? We basically know that the value of the z is affected by the confidence level. Because just now, right, you know the confidence level, therefore you can find out the value of the z. Now we want to do it the other way around. To get the alpha, we need to know what is the value for the z first. Okay, and we are going to use this formula and start our calculation. Alright, so let's start. I know that we are having width equals to 2z, then square root pq over n. Let's put in all the value that we have here. What is the width? Given in the question, it is 0.04. 2, z, I don't know what is the value, that I keep it as z. The P that we get just now is 7 over 50. Q that we get is 43 over 50. And the number time of experiment that we repeat is 500 times. Okay, then from here, let's try to get the value of the z up to 3 decimal places. So I'm having the z equals to 1.289. Alright, yeah, then how can I get the alpha? Let us recall again the diagram that I drew just now, because we know that this is basically a normal distribution. Okay, and then like what I told you just now, we are having one negative value for the z and also one positive value for the z. And this z now is 1.289. We already calculate the z just now, right? Okay, and what is the alpha? The alpha percentage is this one. This is alpha percentage. Or you can write alpha divided by 100 also can, if you are talking about the proportion. Okay, all right. So this part is alpha. Yeah, then now how can I get the alpha? I realized that it will be easier if I can try to find out this blue color area first. Okay, I want to find out this blue color area first. So this particular blue color area, if I write it out in the symbol form, it should be the probability of z greater than 1.289. Agree? I want to find the blue color area more than on the right hand side of the z, so more than 1.289. Then I have to take 1 minus, where is the 1.289? Refer to the table. 1.2. 1.28 is here. Then 9. Just make sure don't do careless mistake. Yeah, 9 is this one, right? Which means that you have to take 8997. You have to add 17 at the last two digits of your value. And by right, if you didn't do any careless mistake, this is 1, then 0, then 9. Okay, if you didn't do any careless mistake, by right, you should be having 0.9014. Okay, so we go back here, you should be getting 0.9014. Then you are getting 0.0986. So this blue color area, you are having 0.0986. What happened to this part? They are symmetrical, right? Therefore, this is also 0.0986. Therefore, how can I get the alpha, basically? To get the alpha, what we need to do is, I have to take the whole graph, which is the 1, the probability, total probability is the 1, minus 2 times of 0.0986. Correct? I have to take 1 minus this blue color area minus this blue color area also to get the center. Right? So after I get the center, it is in the probability form or it is in the proportion form. I have to multiply it with 100% to make it become the percentage. And what do I have here? I'll be having 80.28%. And therefore, you'll get 80.3%. Which means that in this case, what is your alpha? Alpha should be equals to 80.3. Correct to 3 significant figure. Okay, all right, yeah. So this is how we solve the question number 5. Question number 6. We are given the length in centimeters of worms of a certain type is modeled by the probability density function, like this. Okay, and the length is between 5 to 10 cm. The x is defined between 5 to 10 cm only, right? Okay. They want us to state the value of the mean. EX means the mean, right? And only 1 mark is given. All right, so if you want, you can try to integrate it if you want. All right, because we are having a formula where to get the expected value of the x, you are having all x, integrate all x, then multiply the x with the function first before you integrate them. And you can see that this step will be long. Okay, if you want to apply the integration, but only 1 mark is given here. And how can I get the mean value in a shorter way? So you need to know another fact, okay, where if the function fx is symmetrical, all right, then the expected value of the x is the midpoint or is the center of x defined. This is sorry, this is the extra fact that you need to know, yeah, okay, in a probability density function. Okay, then we are going to use this one. So let's have a look whether our function fx is symmetrical or not. If you have a look for this graph, you're having 10 minus x and also x minus 5. If you try to make it become 0, you realize that your diagram will be something like an N shape. You're having negative x squared. If you try to expand it, so you're having something like negative x squared. Let me have a look, yeah. If you try to expand it, what do you get? You'll be having negative x squared, then plus 15, x minus 50. So you can see from here, you're having negative x squared. It should be a quadratic equation, but having an N shape. Positive x squared means U shape. So negative x squared means N shape, right? And then if you try to substitute y equals to 0 and you solve for this function fx, you'll get the x-intercept at 5 and also 10. Then to draw a U shape, to draw an N shape, your graph will look something like this. And where's the midpoint? Because it is a quadratic equation, therefore the center will be somewhere here. Okay, so what's the midpoint for the graph? So it will be as 7.5 lah, 5 plus 10 divided by 2. And by right, you should be having 7.5. And this 7.5 is the midpoint of the x defined, right? And it is also the value of the mean. Okay, therefore the expected value for mean is, value for the x is basically 7.5. You no need to show the steps, but basically you need to understand or you need to remember, all right, the particular fact here. Right, but of course, if let's say you can't remember it, then you want to apply integration, still can. You can still get the same answer. Just that it is not so worth because of the step is long, but you only get one mark here. All right. Okay. So from here, you can see that basically you still need some basic knowledge in AS Pure Math syllabus, where you need to know how the graph look like when you are having a specific function. Okay. Right, then let's have a look for part B. For part B, they want you to find the variance x. Okay, before you want to find the variance x, usually I will tell the students, you try to integrate first and try to figure out the value of expected value for x squared first. So we're having all x, multiply the x squared with the function first before you integrate them. After you get this answer, only you try and find out the variance x, where I want to take expected value of x squared minus the mean square. Okay, so let us start. Find out the expected value for x squared. The value x defined is 5 to 10. So my lower limit is a 5, upper limit is a 10. Multiply the x squared with the function. So the function is this. Okay, again, personally for me, I prefer to take out all the constant first before I start the integration. Then for the two brackets here, you need to try and expand them. By right, you'll be having 10x minus 50 minus x squared plus 5x. Then only I multiply the x squared inside and simplify them. If I multiply the x squared inside and simplify, by right I will be having 15 x power 3 minus 50x squared, then plus, still minus, right? Minus x power 4. And kindly take note that in this part, of course, you need to apply some concept in pure math integration. All right, then you need to know what kind of function you can integrate, or how should you simplify your function before you can integrate them. All right. Okay, then now I successfully get the pattern of the function that I can integrate directly. So let's integrate them now. Power 15 is a constant, I just copy. X power 3, I integrate it. Power plus 1 become the 4 divided by the 4. Okay, minus 50 is a constant, I just copy it. X squared, power 2 plus 1 become a 3 divided by 3. Then simply happen for x power 4, power plus 1 is a 5, then divided by the new power 5. Then substitute in the value of 10 and also 5 into your equation, into your expression. Okay, let's substitute 10 first. If you substitute the 10, first term you'll be having 37500 minus, substitute the 10 into the second term here, you'll be having 50,000 divided by 3. Then substitute 10 into the third term. I didn't simplify it, I just write it out directly. So 100,000 divided by 5. Okay, then now I want to substitute the value 5. Okay, so minus, substitute the value 5. Substitute 5 inside here. First term is 9375 over 4. Second term is 6250 over 3. And also minus 625. Then you try to press calculator. Make sure you don't do any careless mistake. Double check every time. Then you get 57.5. And please don't be happy too early, because this is not the final answer for variance yet. It is just the value for x squared, expected value of x squared. Then let us continue for extra one step here. Let's figure out the value for variance x. Formula is expected value for x squared minus the mean square. Okay, then I'm having 57.5 minus, what's the mean just now? When you get 7.5 just now, then we square it. And by right, you'll be having 1.25 as the value of variance. Alright, so this is what we have for part B. Okay, then let's continue to part C. Okay, two worms of this type are chosen at random. So now we are having two worms. Find the probability that exactly one of the worms has the length less than 6 cm. Okay, let us focus on probability of length less than 6 cm first. Probability means P. Length means the X, right? Length is the X, yeah? Less than, smaller than. 6 means 6. Okay, to find the probability, you need integration also in the probability density function. So smaller than 6 means that x starts from 5 until 6. Okay, what is the function for fx? 6 over 125. 10 minus x, then x minus 5. Then again, do the same thing. What I do is like I try to factorize out the constant term. Take out the constant term, then I'm having expansion for the brackets, then 15x minus 50 minus x squared. Then only I start the integration. Okay, so what is the integration here? 15 x squared over 2 minus 50x minus x power 3 over 3. I think all this integration you should be familiar with it. It is a simple integration only. Right. Okay, then let's continue further. Substituting the value of 6. Okay, then if you simplify, you are having 270. Substitute the 6 into the second term, you'll be having 300. Substitute the 6 into the third term, you'll be having 72. Then minus, now I want to substitute the 5 inside. Substitute the 5, first term you are having 375 over 2. Substitute into the second term, 250. Then after that, 125 over 3. Okay, then simplify. If you didn't do careless mistake, this is the answer that you should have. Okay, all right. But of course, this is not the final answer yet because what do we have in the question? We are having two worms in total. Then one of the worm is less than 6 cm. Okay, all right. So how can we do this kind of question? Okay. So we can make it in this way. To find the probability, maybe the first worm is less than 6, so 13 over 125. Then the second worm is not less than 6, so 1 minus 13 over 125. So this is worm number 1, this is worm number 2. Then for your understanding, this one is x smaller than 6, that means the length less than 6. Then for the second worm, the length is not less than 6. Okay, therefore I have to take 1 minus less than 6. This is first worm, second worm. But you are also having the other case where the first worm is more than 6. Then the second worm is less than 6. This is another possible case that we have for this probability. Okay, this is more than 6, this is less than 6. So if you try to figure them out by right, your answer should be 0.186368. And then correct to 3 significant figure, answer should be 0.186. Okay, this is one way. And then you need to know that if you are using this way, right, you have to consider worm 1 and worm number 2. Then what is their length? Okay, there's another way. Some students, they might aware that, oh, basically, right, this belongs to binomial distribution because you're having two worms in total. One of them something, 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 right? Yeah, so the second way is you can treat as a binomial expansion where you're having two worms in total. So 2C1, number of worm less than 6 is a 1. Then you're having 13 over 125 power 1. Then Q is 1 minus 13 over 125 power 1. Then again, if you try to simplify all this, you will get the same answer as well. So it depends on how are you looking at the particular question here. Some students, they might able to identify that this is a binomial distribution, of course, you can directly use the binomial distribution here. Okay? Yeah, so I think this is how we answer question number 6. Okay, question number 7, the last question for this paper. The market researcher is investigating the length of time that customers spend at an information desk. He plans to choose a sample of 50 customers on the particular day. Right, so 50 customers. He considers choosing the first 50 customers who visit the information desk. Explain why this method is unsuitable. He only focused on the first 50 customers. When you want to do any investigation, like any survey or whatsoever, right? There's one very important fact that you need to know, where the sample must be random. That means random means that it is not focused on a specific time, a specific group, but it should be chosen randomly. So this is the reason why the method is unsuitable, because for this researcher, he only focused on the first 50 customer. That means he only focused on the customer who reached earlier. All right, and this is not random. If random means that he should select the customer from different time frame when they arrive or visit the information desk, right? So the main reason is this is not a random sample. And why this is not a random sample again? You need to tell them that it only focus on only focus on the customer that come earlier. All right, so this is what we have for part A. And let's have a look for part B. The actual length of time in minutes that the customer spend at the information desk may assume to have a mean of mu, variance 4.8. The researcher knows that in the past, value of mu was 6.0. He wishes to test, I think the keyword is out here, it is a test, hypothesis test question, at the 2% significance level, whether this is still true. He chose a random sample of 50 customers and note how long they each spend at the information desk. State the probability of making a type 1 error and explain what is meant by type 1 error in this context. Okay, so first of all, we need to know when we want to carry out this particular test, right? What is the distribution that we are using? You can see that we don't know the value of the population mean and we wish to carry out a test on this population mean here, right? Okay, they assume that it was 6 for the population mean and they want to know whether is the value still true. Okay, we are focusing on the population mean. To do any testing on population mean, we are using normal distribution. And how can we make sure that the information that we have is normal distributed? They didn't mention that population is normally distributed, but you are having the sample size which is large. Okay, so the n is greater than 30, which is large. And then according to the central limit theorem, okay, you know that the sample mean will be approximately normal distributed as well. Okay, so to carry out this test, right, we are testing the population mean. Okay, we will assume that the the sample mean is normal because we used a central limit theorem. When you are having normal distribution or normal distributed, this is continuous random variable. When you're having the continuous random variable, the type 1 error is equals to the significance level. Okay, so you can write here, the type 1 error is equals to the significance level 0.02. So there are many information here and also there are many small details that you need to know. For those who are not so sure what am I talking about just now, then maybe you can go to the channel and search for some videos. Okay, the lecture videos, I did mention in the lecture videos. All right, what is the type 1 error? When will the type 1 error equals to the significance level? All right, when you are having a continuous random variable in your testing, then your type 1 error basically will be your significance level. So I answered the first question here. They asked us to explain what is meant by a type 1 error. In the context of the question, yeah? So type 1 error means reject the null hypothesis. Wait, type 1 error means reject the null hypothesis when the null hypothesis is true. Okay, then how can I put this in the context of the question? So you can say that we conclude reject the null hypothesis. Reject the null hypothesis means that the mu is already different. So we conclude that the value of mu is not the 6 anymore. Although the null hypothesis is true, although in fact the mu is equals to 6. Okay, so if you have a look in detail, this part is reject the null hypothesis, and when this is the null hypothesis is true for the second part of the sentence here. Okay, all right, then after that, let's have a look for part C. Given that the mean time spent at the information desk by the 50 customer is 6.8 minutes, carry out the test. All right, so to carry out the test, we need all the important values here. Let's have a look, yeah. What are they giving us in this one? They said 50 customers, the mean time spent is 6.8. So this 6.8 basically referring to the value of the sample mean, because the mean is coming from this 50 customer, which is a smaller group. Okay. All right, so to carry out the test, let us set up the test step by step, yeah? So first one, we know that in the past value, mu is having 6. 6 means 6 minutes here in this case. Okay, what is my alternative hypothesis? If you have a look from the part B in the question, they are interested to test whether it is still true. Still true means that they want to know whether it is still equals to 6 or not. Okay, so equals to 6 belongs to null hypothesis, right? Therefore, alternative hypothesis means not equals to 6. Okay, so this is the first step that we have. Second step, we want to carry out, we want to find out the critical value. For me, I know that it is a normal distribution, and I want to find out the critical value. All right, so for the critical value, I know that for this particular test, it is a two-tailed test. How I know that it is two-tailed test? Because from alternative hypothesis, it is not equals to. Not equals to means that can be greater than, can be smaller than. Therefore, the rejection region might appear at one of the side. So we are having the two rejection region here. And what is the area for these two rejection region? It is equals to the significance level. And in this question, the significance level is 2%. And I want to separate the 2%, divide the 2% into two parts here, which means that each part will give you 0.01. 1%, so 0.01 in probability. This is also 0.01. Then what happened to the center part here? It will be 0.98. What do I want to find? I want to find the critical value in this case, and this is the critical value, Z. Okay, then how can I get a critical value? You have to find out the table in the reverse way. Then let's refer to the whole area below the Z, yeah? So to find the value of the Z, I'm referring the whole area below the Z in this case. So the whole blue color area here that I shape out, that I outline it. Okay, so what is the total area for this blue color part? It is 0.99, right? Then to look for the value of the Z, again, we go to the shortcut table first. See whether is there any 0.99. Yes, there's a 0.99 here. And the value of Z that we have is 2.326. Okay, Then go back. Your Z here will be 2.326. The same thing happened here. The other critical value at the negative side will be having negative 2.326. Okay, so this is my second step where I try to find out the critical value. Then let's continue to the third step. So for the third step, I need to calculate the test statistic. Okay, so test statistic. To get the test statistic, it is a value of Z. You are taking sample mean minus the population mean divided by sigma over square root n. Sample mean, like what I told you just now, it has been given here, 6.8. Population mean is the value that you want to test, which is a 6. Sigma, which is the population standard deviation. We are given the population variance, which is 4.8. Excuse me, 4.8, yeah? All right. So I want to use the square root 4.8 as the standard deviation here. So we are having square root of the whole 4.8 over the sample size. Sample size here is 50. Get the value of the Z. By right, you should be having 2.582. Okay, so this is the third step where I try to calculate the test statistic. After that, I want to decide and see where my test statistic falls under. Is it fall under the rejection region or is it falls under the acceptance region? So 2.582, if I want to put it inside this diagram that I drew just now, this particular line, the border line between the acceptance and rejection region is 2.326. 2.582 will be after the 2.326. So this value will be 2.582. And from here, what do you see is it falls under the rejection region, correct? All right, so from here, I can make a decision already lah. But before that, I try to write out the comparison statement first. Test statistic 2.582 is basically greater than critical value, which is 2.326. So what's our decision? It falls under the rejection region, right? Therefore, we reject the null hypothesis. Then please make a conclusion in the context of the question. So we reject the null hypothesis means that the value of the mu is no longer equals to 6. Okay, there is sufficient evidence to show that the value of mu is not equals to 6. Okay, yeah, so this is a complete test that we have here. All right, then let's have a look for the last part. Part D. Give a reason why it was necessary to use a central limit theorem in your answer to the part C. Okay, so just now I think I tried to explain a little bit, right? We are using the central limit theorem because in the question, they didn't tell us what is the distribution for the population. Okay, so you need to just let them know that population distribution is unknown. Okay, yeah, so I think this is the last question that we have for this paper. Thank you very much for watching the video.